Alright, so this is grade 8 IXL section J.4, looking at the percent of one number, how much that is of another. And in this case, this is just division. So remember, percent is percent, which simply means per 100, or that per can mean for every 100. So this is our ultimate goal, to find some percentage. We're going to divide. So if we look at this first one, new speed limit, there's out of 50 votes, remember that is going to be the whole, 35, that is the part, were in favor. So what percentage was in favor? So we have the part over the whole. And since our goal is to have this as 100 on the bottom, we can think, well, I can multiply 50 times 2 to get 100, but whatever I do to the bottom, I have to do to the top. So 70. And now it's out of 100, so that's my percent, so this would be 70%. 70%. So that's what we're looking at, percent per 100. So let's do a few more. We have some beads. Here's the total, 825 beads. In this case, 396 were orange. What percentage of these were orange? So we have 396. So this is a little bit harder because this is just simply a bigger number. But if I use my divisibility rules, I can see that they're both, well, they're divisible by 3 to start. I know that because 9 plus 3 is 12, plus 6 is 18, and 18 is divisible by 3. 8 plus 2 is 10, plus 5 is 15, and that's divisible by 3. So we can divide both of these by 3. In this case, we have 132 on top. 3 goes into 8 2 times. 2 left over. Goes in 7 times with 1 left over. And goes in 5 times with none left over. This one's a little bit harder because there's nothing that clearly goes in easily. I see this one's even, so 2 goes in. 32, 4 will go in, but this has a 5, so it means 5's got to go in there somewhere. In this case, is where we have to use a little bit of sort of intuition to say, well, let's go ahead and break this down and see what is left in this one. We divide 5 in. 5 goes into 275. Well, it goes into 27 5 times with 2 left over, 5 and 25, so it goes in 55. So this one then becomes 5 and 11. Since I have 5, 11, and 5 as my factors for this one on the bottom, and 5s don't go into the top one, I can pretty much guess that it's going to be 11 on top. And sure enough, I recognize this as a multiple of 11. In this case, this is going to be 12 times 11 to get 132. And in this case, it'll be 25 on the bottom because I just divide out this 11, and everything that's left is 5 times 5. Well now, 12 out of 25, we can make that into 100 by multiplying by 4 and get 48. 48%. So this one's a little bit harder because of the number they gave you. So be careful on those. Let's do a couple more examples. Alright, so we have 225 cars, 189 traveling east. What's the percentage? So this is straight division. Here's our part, and here's our whole. Again, we use what we know about the divisibility rules to see that 9 will go evenly to this one, and 5, 6, 7, 8, 9, if we add these up, will go in here as well. So using short division, 9 goes in 18 twice, the remainder is 0, and 9 into 9 is once. 9 into 22 goes in 2 times with 4 left over and 5. So in this case, 21 over 25. This is very similar to the last one. We simply have to multiply both by 4 to get it to be a percent per 100. So remember, we always are working part divided by whole equals some percentage over 100. So in this case, 21 times 4, 4 times 20 is 80. 4 times 1 is 4, so this is 84 or 84%. this one's a little bit different because we have 276 students who wore yellow and 324 who wore green. What percentage wore yellow? So instinct says, oh, I see two numbers. We simply have to divide the students who wore yellow by, oh, wait a minute. Remember, it's always the part over the whole. So in this case, the whole is the number of students who wore yellow plus the number of students who wore green. So 3, 4, 5, so this ends up being 600 students total. That's the total students. And that means that it's the part is 276. But this is not our whole. This will be the whole. And we can do some division. I see that this is even and divisible by 3, as is this one, so I know that these are both divisible by 6. So using short division, bottom is 100. Oh, this is looking great because it's now already in percent form. 6 goes into 27 4 times with 3 left over. 6 goes into 36 6 times, so this is 46%. So again, this is where they'll trick you. They'll give you the two different sides, but they won't give you the total. You will have to find that yourself. Right, so now they've given us a graph of it, and this is really no different than the last one. So we want what percent of this guy's votes, Leon's, were from 7th or 8th grade. So we want all of this. So he's got 600 and 100, so he has a total of 700 votes. Out of, well, there are also 700 6th grade votes. So 700 out of a total of 1,400. Hopefully you can see that is 50%. So this they just give you into a different form. You have to add up what they've given you. And since he had half the votes, that's 50%. Alright, so again, same idea. What percentage was scored by Preston, Clive, or Kenji? So now we have multiple ones. Preston, Clyde, or Kenji are all of these. If we add these up, this is 100 plus 100 is 200, 290, 310. So this is 360 votes. 1, 2, and 240. So it's a total of 600 votes. Sorry, points, rather. These are points. 600 points, of which those 3 people scored 360. You can instantly get rid of those zeros, and I see that 6 goes into both. So this becomes 6 out of 10, which, when we put those zeros back in, actually becomes 60%. And this is straight division, reducing fractions to some factor of 100 that we can then multiply to make it a percent. This will be our last example. We have 3 beauticians, and how many are for yin? So that's the part in this case, is how many for this one person, which is 210 out of the total. Now there's a little hint here, round your answer to the nearest percent. So that means this is not going to work out evenly. So let's go and add this up. Let's see, it's 1,013. So this is 1,410 votes total, 1,410. We can get rid of this zeros here, and I see 21 over 141. So this looks to be about a 1/7. So my estimate is about 1/7, which I know to be approximately 14%. So we can then say, well, 3 goes into this one, 4, 5, 6, 3 goes in here. So I can say, do a little short division. We get 7 over, 3 goes into 14, total of 4 times with 2 left over, and 7. So now I know 7 divided by 47. Alright, so this one's not so easy because we've got a prime number. So we've got to do some long division, well, some short division on this one. But it's not going to be very easy. So we've got 7.000, and we have to go at least 3 places if we're going to round to the nearest percent. So 47 goes in 1 time to 70 with 23 left over. Now 47 is just below 50. 50 goes into 230 about 4 times. And so 4 times 4 is 160. 4 times 7 is 28, so 160 and 28 is 188, which means that it goes in 42 leftovers. Now, I just have to note, does this go in at least 5 times? And sure enough, it goes in 5 times, so that's all we care about. But if we really want to know the true answer here, say, well, this is close to 50, so it goes in at least 8 times, and 8 would be 320, plus 56 for 376, which would give us just enough. So that sure enough rounds up to 15%. So again, this is a little more advanced. This is up in the 80th, 90th percentile for your SMART score. But understanding that reducing first and then doing a short division is the way to go. But I also had a little estimate here as well, because I noticed how close this was to 1/7, and I know this is 14.28%, 1/7. And so using that, this gives me a pretty rough estimate.